right, so before I begin, I'd like to just let you guys ask me questions so I can, there's no prepared slides, there's no prepared talk here. This is demo, answer your questions, show you what this tool can do.
Yeah, I just came actually to kind of see what all it could do.
Okay.
I've used it once to find queries that weren't using indexes and got mixed results on different versions of MySQL.
What was mixed results?
It
Crashes
didn't work on 5033 and didn't work on 5088.
Okay. What didn't work? Did it crash or just
No, it
give you
just
the output you
didn't
wanted?
give us the output we wanted.
Okay.
I mostly use for slow queries.
Okay. Anybody else? All right. This is this to. Okay, so MK Query Digest began its life as a tool called MK Log Parser, which was there were a lot of slow query logging analysis tools out there, but none of them had a single damn test. And so if there was any variation in the log formats, for example, if you were using a micro-slow resolution log format, or if you were using the Percona patched log format or whatever, they would just blow up, and it was endlessly frustrating because they were all written in Perl, and it was really nasty Perl. This tool is also written in Perl, but it has tests. It has a lot of tests. And I started writing a log analysis tool with tests from the get-go. And that was really the point. After a while, MK Log Parser became more generic. It became able to do more than just parse logs. And we realized that we had built a pretty clean internal architecture, which I'll describe a little bit. And so we decided to change the name to MK Query Digest. And the name reflects the fact that you can use it to consume any source of query events, or events that you could consider to be a query, i.e. a question that has an answer. And then you can aggregate and transform and filter and print out and store in a database and do whatever. You can digest them in lots and lots of different ways. We wanted to keep things pretty simple so that it would do something well right out of the box. So if you just run it with a log file, or if you run it with standard input or something like that, what it does is it assumes that it's reading a MySQL slow query log format, and it assumes that you want a report on which queries in there are the most interesting in aggregate. So that's the one thing that it does well. And then it has about 80 command line options, I would guess. So lots and lots of command line options that make it sing and dance and do various different things. So I guess I'll start with where the tool started, with slow query log analysis, and then we can move from there, because there's some pretty complicated and interesting different stuff that you can do from there. So here I am in the Modkit code directory, and there are a whole bunch of slow log examples in our test suite. So I'm just going to use these examples to demonstrate what it can do.
Are these bound with the full source, you're saying? These tests?
These tests are part of the Modkit code repository. Yep. So I'm just going to pick one. I have no idea which of these are anything interesting. And just run it against that. So it produces a report of the queries in that log. Looks like this is a very small log with only three queries in it, so it's not terribly interesting. But the default behavior that we wanted was to examine a slow query log and figure out if you're looking, there are two kinds of things that you might be looking for on the system. Queries that are causing the most load on the database, which are accumulating the most combined execution time, or queries that have an unacceptably slow response time. So there are kind of two dimensions there. And it ranks everything by aggregated query time. So if I go down and pick out the actual query here, queries that look like this will be aggregated together. So it's basically a group by over all of the queries in the slow query log. And it abstracts queries out so that it can group them together. So for example, if that query had happened to be select star from user where user ID equals 1, it would abstract out the 1 into a question mark, and then user ID equals 1 would be grouped together with user ID equals 2, user ID equals 1,000,000. Those would all be considered the same query, and they would be aggregated together and reported on as a group. So let me go back to the beginning, and if any of this is stuff that you guys all know and is really boring, just tell me to skip and I can skip ahead, or tell me what else you want to know and I can tell you. The first little paragraph here is a report about the contents of this log overall. The first thing here is actually a report about running, about how much resources it consumed to run this program. So we can skip that. This is mostly useful for it's mostly useful for development, actually, because we had to rewrite the log when we started parsing 10 gigabyte logs with servers that only had 150 or 200 megabytes of memory free. It will do that now. As far as I know, it's the only tool available that works in essentially fixed memory. The memory is not completely fixed, but you can throw many, many gigs into it, and it will not continue to eat memory. So that first line tells you about the performance of the tool itself. And then there's a line about the overall contents of this log file. There are 3 total queries in this log file. There are 3 unique ones. If some of them had a similar form, they would have been aggregated together, and you would see, for example, 2 unique queries in the log or something like that. And then there's some information about how many queries per second and the level of concurrency on average in the log. And then we start to grab out a table of properties, and we start to grab out the properties from those query events and then build a table of the results. Now these are statistics. So for example, the first column is the total of execution time, the total of lock time, the total of bytes in the queries. And then you have minimum, maximum, average, and then finally the 95th percentile, standard deviation, and the median, which is important because these things are not normally uniformly distributed most of the time. A lot of times they'll follow a normal distribution, sometimes they'll follow some other distribution. But for example, if you're interested in the 95th percentile response time of your queries, this is a really good way to get it. Or, yeah, I mean, there are lots of places in performance analysis where you want to know the 95th percentile. Morgan?
Out of curiosity, are there any bugs to get like a 95 and a 99?
No, there isn't. It could be done, but the statistics is actually what consumed the memory before the rewrite. So what we've done is we've, instead of, for example, to calculate the 95th percentile, the standard deviation, the median, those things, you actually have to keep track of all the values you've seen. So if you have a 20 gigabyte query log, that's a lot of stuff that you're keeping track of. So what we did was we broke it up into buckets of increasing values, starting at a very small value and then increasing exponentially all the way up to a very large value. And then when you see, for example, a query time, you just go, well, that fits into this bucket, and you increment that bucket. This is how we do it in fixed memory. And those buckets are 5% apart from each other. So that makes the 95th percentile response time pretty easy to do. You just go, I get everything all the way up to the 95th. I'm going to mess up the math concepts a little bit here because this was kind of complicated to get right. But you throw away the top bucket and you say you sum up everything else, and then you've got your 95th percentile. Okay, so this first paragraph, we've kind of looked at the first paragraph. That is the log file overall. Most of the time I don't spend much time there. And actually I'll show you later what I normally do is I don't even start at the top of this report. I go right to the bottom. And then each paragraph after that, let me scroll down. This doesn't quite fit on one page, but each paragraph after that is a report about a distinct query, what we call a fingerprint. So this process of abstracting the queries out, abstracting out the user ID and those kinds of things is what we call fingerprinting, and then you arrive at sort of the canonical fingerprint form of a query, and each of these paragraphs is a report about that. So first line says this is the #1 query ranked in terms of aggregated response time, and then you have these same queries per second and concurrency metrics. And then you get the query ID, which is actually a hash. It's a CRC32 or an MD5, I forget which, of the query's fingerprint itself. This is a nice identifier that you can use as, for example, the primary key in a database or something like that. And then this last little bit at byte 491, I'll explain that a little bit later. The next line tells you why you're seeing this query. You're seeing this query because it is within the set of queries that comprise the top 95th percentile of response times in aggregate. So if you wanted, for example, to see, by default, this tool will show you all of the queries that are together constitute 95% of the response time in the entire log.
Can I ask a question about a couple of rows there?
Yep.
Rows sent and rows examined. How do you get a bigger number sent than examined?
That's interesting. I don't know.
Like that on
We would have to look at the source log file that this came from.
see what they're really meaning.
Yeah. So this may be some bogus log file that we hacked together to reproduce a particular bug, for example.
Okay.
So that may be bogus.
And the lock time. What lock times is included?
Okay. Yeah. Lock time is part of the standard MySQL slow query log format. So
it's not going to be like it'll be row level.
no, this is lock time at the server level. Now, if you're using the Percona patched server and you have log verbosity set up high, you get a whole bunch of statistics about InnoDB. And the tool auto-detects by looking at the first 100 events. It notices what kind of properties are in each log entry. And then it actually writes itself some code that it can execute after that. I think it's the first 100. That's a command line option, one of those command line options. It processes 100 events, and then it goes, okay, this is the set of attributes that I've seen in these log events, and I'm going to write myself some code to do this faster from now on. It actually builds itself compiles itself some functions after a little while, after it's kind of figured out what sort of input it's getting. And so if you throw a Percona patched server with a whole bunch of stuff, you will see this table will get very big because there's lots and lots of properties that it's aggregating and reporting on. So
Wait, is that the user stats?
yeah, the user stats query, and there's a couple of different patches that we've built there. So this table is actually a little bit bigger than the overall table that we saw at the top. There's a couple of columns here, like percent of total is the first column. So there were 3 queries in this log, and this query executed 1 time, so unsurprisingly it is 1/3 of the total queries in the log here. The execution time, lock time, row sent, etc., those kinds of things. You get to see the distinct users. In this case, you only see one user, meow. Obviously, this is a hacked up example log, right? It'll print out a number of them, comma separated, and it'll show you the count of each of them. And then after that, if there's more, it'll just kind of give you a ... and tell you how many more it didn't print out.
Can you actually filter by user to begin with?
Yeah, you can filter by anything. I'll show you how to do that. That's a good question. I might not have thought to do that otherwise. And we've got hosts. Apparently the host was empty in this query log, and databases, and then the bytes. And then finally, here there's a histogram of the query time in exponential buckets of powers of 10. So most of the time this will be some kind of a graph. A lot of times it will be not normally distributed. It'll have 2 peaks, like it'll have 1 peak and then another peak around, maybe you'll see that most of the queries clustered around 10 microseconds, and then a bunch of them clustered around 1 second or something like that. It examines the query and combines that with the database that it noticed up here. hopefully this is relatively clear to you guys as I highlight parts of the screen. And then pulls out the table and database names and makes you some handy little hints here that you can run if you are, for example, trying to find the trying to optimize this query. You can go and easily examine the structure and the status of this table. And similarly, we add an explain in front of things so you can copy and paste explain directly into your database and get out some explain output. If this had not been a select query and it made sense to do so, it would also have transformed it into a roughly equivalent select that you could explain. So for example, if it was update foo set user equals foo where 1 equals whatever, it would kind of extract all of those parts and turn it into a select that roughly approximates the same where clause and things. And that's about all. Just repeat, repeat, repeat. There will be more and more of these kinds of queries. In this case, we see, going back to the top, there were three total queries in this log, and there were 3 unique. But as it turns out, when we got down to the bottom, that was it. That was the last one. It only printed out one of them because only one of them was either too slow or contributed to the 95th percentile of the response time in the log. And then what I usually do, this is the part that I usually look at first, is this last little bit in the report. It's not terribly interesting here because we only have one query in this response time profile table. But I usually look at this first to see whether there are any queries that are actually worth optimizing. So I'll look at the response time and the percentile of the response time, because when you're doing query analysis and optimization, you want to focus your attention on the things that contribute the most to the response time or the load, whichever way you're looking at it. And you want to know whether you've got a chance to actually make a difference in any of those. So for example, we can see here that the response time per call was just under 200ths of a second. And maybe we can make that faster, maybe we can't. But when you get 8 or 10 of these in a table, you can see pretty clearly which ones you need to focus on. It's either ones that have lots and lots of calls or the ones that have a really slow response time per call, and you think you can make a big difference by speeding them up. Yes?
Why did it pick select star from foo if there were many queries that matched that pattern?
There were not many queries that matched that pattern.
Well, here's a bad example, but I just wanted to, that's one of my favorite features, is the leading question. I wanted you to share why it showed that example.
I'm not quite clear. The actual query that it, this is the actual query. Oh,
A better example.
I think I see what you're saying, and I skipped over this. Okay, so this is not the abstracted form of the query that I've highlighted here. This is one of the samples, one of the real actual samples from the log, so that you have a real sample that you can explain and re-optimize and those kinds of things. And it picks the one that has the worst response time in the class. So it's if the maximum time for this class of queries was 3 seconds, then the sample that you get there ran in 3 seconds.
Yeah, that's my absolute favorite feature. It's just really nice to learn.
Right. Yeah, because I don't know of any other tool that does that. A lot of them will just give you some example of the query, like the last one or the first one or a random one. But this is the worst one. And there's command line arguments for practically everything here. You know, you can massage and manipulate and tell it to sort by this or order by something else or aggregate by something else. And I can get into a lot of that if you want. But unless you have a specific thing that you're going after, I mean, just run it without any arguments and you get a report that's useful for reducing the...
Coming back to this query ID, knowing your style, I'm sure you can create a table where you can insert also results.
Yes.
And probably this is where you can use query ID and compare it day after and months after.
Yep.
Can you please go into more sophisticated flags?
Yes, I can. I'll show you that.
Especially non-documented ones.
No, they're all documented. There's that's one of the things that one of the decisions that I'm happy we made about this project. The documentation is the command line options. They come, the tool actually examines its documentation defined its command line options. So there is no undocumented command line option anywhere, ever. The documentation may be wrong. It generally is not. It generally is, and in fact, the documentation actually examines itself as well. So if you look at the -- help output, for example, let's look for the word default. Okay, so we've got, it's default 1000, not 100. This is what I was mentioning before. How many events you process before you go, okay, I think I've kind of seen the format of this log, now I'm going to build some custom compiled code to do it really fast. It says here default 1000, and that default is 1000 because it's actually looking in the specially formatted documentation, which is just printed out here, and extracting that pattern, parentheses, default 1000, and going, well, 1000 is the value.
So if you want to change your behavior, just change the documentation.
If you want to change your behavior, change the documentation. We do that in as many ways as we can. That way, there's no disconnect between, I got really, really tired of updating documentation, updating the help output, and updating the defaults and all those things in different places.
And a question which I always wondered about configuration. You put also gazillion flags after, in this case, digest. And is it any way to pre-create a config file for you, so next time you run it's there?
I should have been writing down your questions so I make sure I don't miss any of them. Yes, we do.
Do you want someone to note take at the same time? Or do you want to-
Somebody had volunteered to take notes. I just need a scrap of paper so that I don't forget to cover any of these. So we had filter, we had store in table, and we have config file. Okay, so let's go over them in that order, if that's okay. So we can filter. It helps if you know Perl, but there are good examples in the documentation of how to write filters, because a filter is actually a Perl expression. So if I wanted, let's just look at that slow query log that I just looked at. Let's look at the raw log and see what's in it, just so we have some examples. Okay, so this was a manipulated log to make sure that, look at all this crazy output all over the place. There was probably some white space parsing thing that we found a reproducible bug and fixed here. So we've got, the user here is always meow. The thread ID is always 5. It looks like this is not very interesting to filter on. Let's try a different one. Or a different several. We've got root. Here's one of the Percona files, for example. There's no InnoDB statistics for this, but you see there's a lot richer information in here. There's all sorts of things about, this query did not perform a full join. This query was not a query cache hit. The tool auto detects all that stuff and just goes, okay, now I've got lots more things to aggregate and report on and do statistics about. Not
You
necessarily
enable that level of logging.
in the Percona logs.
Yeah.
There's I forget exactly what the verbosity. There's like slow log verbosity.
Verbosity.
Yeah.
Okay.
It's all in the Microsoft patch. We started as just the Microsoft patch.
Yeah, it started as the Microslow patch, and then there was a Microslow InnoDB, and maybe one other as well that adds more stuff in there. So I'll tell you what. Why don't we filter out queries that, this looks like also a contrived, darn, I need a non-contrived example. Let's filter out queries that are slower than, let's say, 0.7 seconds, because I see there's one here that has a larger than 0.76 seconds. And that is slow002.txt. So just for comparison, Only one still ends up in here. Dang. So if we filter out, the command line option is --s filter, and then we write some Perl code, which if it returns true, the filter passes. If it returns false, then that event gets filtered out. I know that wraps around on the screen, but hopefully that's a little bit clearer that you can see what I'm doing there. The event query time is greater than 0.07. Huh, it didn't crash. I wrote it right. And we will see that there's nothing with, there were several queries in this log, but now we filtered that out only to one total query that actually passed that criterion. Okay.
You should have command line again.
Yep. There are examples like this in the documentation. And if you get it wrong, by the way, it won't crash. It'll internally have an error, but it will just keep going. So that was another thing we wanted to do, not get 9 gigs through a 10 gig log file and crash.
Could you do a similar filter to examine only rows? I mean, show queries worth more than, say, 1,000 rows were examined?
Yep, we can do anything.
Okay, cool.
Let me show you how I typically do this. Let me start by stepping back a second. Each log entry gets turned into a Perl data structure, and then it goes through what might be familiar to you as a Unix pipes and filters kind of processing stages inside of the tool. So the first one in there is read the log and extract these events out of it in a Perl hash data structure. And then the next one might be, apply some transformations like get me the fingerprint of the query. And then there's a few more that are applied by default as you go along. Filter actually adds, all it does is add a function into that pipeline of processing events. So the event flows from one to the next to the next to the next, and eventually ends up by default in an aggregator that crunches a whole bunch of numbers, and then when it's done, you've got this thing with a big data structure that you report on. So if you want to know what the structure of the event is, you can go look at the documentation on the Motkit wiki, or you can just do this. Print dumper event. And dumper is the Perl, there's this Perl module that prints out a Perl code readable representation of a data structure. So if I do this, I've just inserted a filter that's going to print out every data structure that comes through this pipeline. So let's see what happens. So there you go. Now you can see all the properties of that. You said rows examined? Mm-hmm. So there it is. So now you can write a filter around rows examined, or any of these other things. There's lots and lots of stuff in here. There's the second query. Here it comes, there it goes. Here comes the third query. So you can kind of see the data flow through this thing. So if I wanted to filter on, whatever that was it rows examined?
Yes.
I do arrow, curly bracket, rows examined, greater than 1,000. And it looks like there is one query that matches that criteria. And rows examined is 61,000. So it worked.
What was the dump command line you had?
Print dumper event. Print dumper $event. I should add that as a hint to the documentation.
Aaron, does that event structure have any information of things you've figured out when you do the pass? Like, does it say what tables are a picture in the state?
No, that comes in the reporting stage of things. So after everything gets aggregated and we choose the sample query to print out, then we actually analyze that sample query, extract the tables out of it, et cetera, et cetera.
This is just because of cost? Or
What's that?
that approach is just because of cost?
Yeah, there's a lot of regular expressions involved that would slow it down a lot. So we've done a lot of work to try and make it fast.
So if I wanted to filter on a table, and I would put a hot table and put columns, I couldn't just use the event structure. Is there a...
Well, what we could do is something like event tables equals, and here you would have to know the code. And I don't know it myself well enough to do this out of memory, but it would be something like query rewriter So now I'm altering that event mid-flight, and I don't know if that's the correct code or not. Let me put this at the top of the screen so it's a little less confusing. So I'm assigning to the tables property, I'm just inventing a new property and assigning a value to it, and whatever the code is here, that would actually be event. The arg is the query of the event. And I don't know whether that's correct or not. But we could do this. I mean, it would be a trivial one-liner, and then we would say something like, event tables matches whatever users to get all your users tables. So those kinds of things are possible. And when you get into nasty, complicated things like this, it's actually easier to do mkquery-digest filter my Perl module.pl and it goes, hey, I see a file with that name and I'm going to treat that, and you can put lots and lots of code in there. Right? So it's much easier to do that than writing it on the command line.
And for that Perl file that you're passing it to, it's just the first parameter that comes out?
It just looks at the argument of the filter option and says, a file with that name exists. Mm-hmm. Therefore, I treat that file as though it contains my filter code. Okay. So it actually evaluates the contents of that file as Perl code.
So if you just had if that thing just returned false, like the file, nothing would show, right?
Yeah.
Okay.
Mm-hmm. Other questions on filtering?
Timestamp. You just convert. How do you filter like in a range of timestamps?
There's actually a -- sense option.
Okay.
Parse only queries newer than this value. That's a little bit. We're getting a little bit of weirdness from grep there, but and it takes. I believe it takes some human readable formats. The same documentation generated from the same source is also available in PerlDoc. So let me go look up the full sense documentation. So here's some of its self-introspection, by the way. It looks at itself and says, that's a string. And parse only queries newer than this value, since this date. And you can give it a few different formats here, including an expression that MySQL can evaluate, such as current date minus interval 7 day. Looks like we have a little bit of a pod nastiness here. Gotta fix that. And I believe there is an until also. Yep. See also until. So that makes it pretty easy to give data resources.
Mm-hmm.
Yeah.
You pass both, yeah.
Yep. Morgan, was there a reason you were asking about tables before?
No, I was just...
Because it just reminded me of this argument. Print a report on which tables are accessed.
Okay.
Which you can use, for example, to determine what tables are unused or if you filter by user, then you can see which tables and what kind of, whether it does reads or writes, that kind of stuff. So let's actually do that. Let's do MK query digest table access slow 002 text, and the output shows that it reads and writes, shows that it writes these two tables.
Can you show again command line?
Mm-hmm. Yeah. You just say table access, and then it shows you which tables were accessed.
Can you actually do multiple files?
Yep.
Why? Because when you get it files from multiple boxes, you want combined report, not like one by one.
Yep. Slow 00 star,
Yeah. Okay.
and it's crunching them, and there we go. So we might have a more interesting. All right. So here's our response time profile now. A little bit more interesting. So I can see that, for example, 23% of the response time was taken by this query number 1, which was select something from bar. This is a little bit interesting. This question mark that I'm highlighting here, not only does it abstract away user ID and those kinds of things, but we ran into a bunch of clients that would have tables that were similarly named. And so we would consider a query against 1 underscore table and a 2 underscore table, and all of those things to be queries against basically the same data structure, so you can aggregate them together and consider them the same table.
And as well, I don't believe you have any server ID in the report, right? So when you aggregate files from multiple sources, and so you don't know whether any particular source created slowness.
Right. There's no server ID in the file, right? So the data has to actually be in the source that you're consuming. Right here we're consuming slow log files, so we have only what the log file gives us.
Sure.
Does this also use TCP dump?
Yep, and I can talk about that.
Can you introduce some extra data into your like slow query log, even synthetically, to make certain information show up?
If you wanted to do that, it handles basically the generic slow query log format with whatever garbage or non-garbage is in it. So if you wanted to add your own stuff, in fact, one of the things that we use this for is, for example, consuming information that looks like a slow query log and printing it out in another format or aggregating it or whatever. You can pretty much throw out anything. So if you enhanced your own slow query log, then it would handle it. And it knows the difference between numbers and strings and all those kinds of things. So it aggregates stuff numerically if it looks numeric. After 1,000 occurrences, it decides whether it's numeric or not, for example. Okay, so storing in a table. And here I have to remember because the command line arguments have changed a little bit. So let's look at the documentation. Review. Review history. Okay, so there's an option to create a table that follows a default suggested structure, which is also embedded in the documentation, which will have that you can create 2 tables, one to hold the aggregated report and one to hold the individual information obtained about each class of queries. And it can stuff all of those things into the table, and it uses that query ID, the 0x whatever stuff, as the primary key. And then there's a bunch of nice functionality around that. For example, if you go and you look through that table and you look at all of the different queries in there, and then you update them, there's a reviewed on column. If you update that to something non-null, then it goes, oh, somebody's looked at this. And next time you run this on your slow query log, it will filter out everything that it thinks somebody has looked at, and you'll only see queries that are new or unreviewed. So this is a nice way to see what kind of what's changing on your database server with basically no installation or anything like that. All you're doing is keeping track in the database of query fingerprints that you have seen and analyzed before. So let me start up a MySQL server on the normal port, so I can do this. And let's actually I'm going to need to make myself a database. All right, so I've got the Motkit database. We'll just call it motkit.review. So that's going to be the name of our table. If I'm getting this right, I may mix this up, but. And oops, it's going to be review table, probably. Let me check my documentation. I actually had a different problem than I thought I did. I said create review and I needed to say create review something further. Alright, so it just parsed that log file and then inserted the results into the database. So if I go back to my database, oh no! Did I do that? Maybe there was an error and it scrolled off the screen and I didn't notice it. I've got a strange artifact here. I think I typed something wrong. Let me fix that and see if I can get this to work. Alright. Hopefully I'm not going too fast and confusing. Okay. I had forgotten that review actually takes parameters to connect to a database server. So host equals review. H is for host. Host equals localhost. The database is Motkit. The table is review. And actually I think I'd better use 127.0.0.1. Otherwise it'll try and connect over a socket and that server's not listening over a socket. Let's see if I get it this time. Yay! We got a review table. And here's the table. It's got a checksum, which is the primary key. It's got a fingerprint, which is the actual abstracted fingerprint of the query. We've got the sample, which is the worst sample. We've got the first and last times that it was seen. We got who reviewed it and when. And then we've got comments and any other arbitrary stuff that you want to put in. Comments is just like a generic suggested kind of a thing. All of these things are pretty much optional and arbitrary. You can put whatever columns you want in here, but it will look for a certain required subset of them. So let's look at what's in that table. And there's one query in there. So we see the big integer form of that hexadecimal ID. We see that the abstracted fingerprinted version of that query and the sample of the query, and then the first and last seen. And nobody has reviewed this yet, so I'm going to update this. And I'll just do it without a where clause to make this quick. Okay, so now I've told Motkit through its use of conventions that this query has indeed been reviewed by Baron now. And next time I run this same command on this log file, it should not have printed that out, unless I did something wrong. Let me make sure I'm not looking at the wrong thing here. Oh yeah, it actually didn't print out that query. It printed out the overall statistics about the whole log file. And I see that our response time profile doesn't seem to respect the query review. We'll fix that. So I'm in this report, I'm basically not seeing, ignore this. Uh-oh, I can't scroll up. The file's not long enough for me to scroll up, so that part on the bottom is hidden. Ignore the part that I've highlighted there. I'm basically not seeing queries that I've reviewed before. So a nice way to kind of see what's new and what is what I have not yet reviewed. There's an enhanced version of this where instead of the just the one table with the overall results that we saw in there of that one query, we can actually store a row in another table for each time that we run this, so we can see a history over time of, it used to run in 5 milliseconds, 5 milliseconds, 5 milliseconds. Oh, now this query is running in 11 milliseconds. What changed? Or now it's running in 100 seconds. What changed? And the intention there in the future is to be able to write a nice little helper tool to examine and print out queries whose performance has changed or something like that. You could do that manually through SQL right now if you want to, but it'd be nice to have a helper tool to do that. So there's some functionality there for the future, or for being able to examine the history of how things used to run and what the performance used to be that's different from now. Okay, did that answer questions about how to store the results in the table? Yes. Configuration. So the config file is really simple. If we look at the -- help output, and then scroll all the way to the bottom, this sort of emulates the MySQL command line files, tools. If you ask them for -- help, they'll also tell you what values they're going to run with. So this is a good way to see what all of the variables and their values are. And you can put this into a file. There are, by default, 3 files that it will read for configuration information through the -- config option. The first one is a global system-wide in etc motkit.conf, and then there's going to be a global system-wide per tool file, so there's going to be one specifically for mkquery digest, and I'm wrong, it's actually 4 files, and then there's going to be one in my home directory for all of Motkit, and one in my home directory for mkquery digest. Okay? And the format of those files is basically, so let's look at this attribute just as an example. The attribute value limit is a sanity check to discover when there's a bug in something that has caused an out of bounds really large value to be put into the slow query log file. So what if we want to change this to 4, for example? mkquerydigest.com, just checking. So the tools, the files are just dot and then named after the tool with a .conf extension. So if I delete the leading dashes and then put 4, I may need to put an equals in there. I'm not quite sure. Let me just test without equals, and let's see. Let's see if that did the trick. Nope, so I might need the equals. 4, ta-da! Okay, so you can put whatever you want in your home directory, and it actually gets, just like the MySQL command line tools, It actually reads that out and then treats it exactly as command line options. It actually appends them to the arguments that the tool itself has received from the command line and then processes them.
And so latest overwrites previous one, right?
The latest overwrites the previous one, and it does them in the order specified in that --config argument. So the global system-wide, the global tool-specific, my system-wide, and my tool-specific. And you'll get all of the normal stuff like warnings about an unknown option or whatever. So if I put into the mockit.conf, I put a specific option that isn't recognized in all of the tools, it'll just say that's an unknown one.
Okay, and now we're getting to maybe a sticky question, because some features of those do overlap between tools, but some only specific to particular tools. Is there any list in documentation which tells which are global, like universal between all tools?
Yeah, I think there is on the wiki. There at least used to be, because I actually created a script that read all of the command line options from all of the tools and created a big spreadsheet table so that we could compare. And we went through this big project where we built this big spreadsheet, and we went, you read across this row and you see that, I don't know, dash verbose means something different in some of the tools, right? So we made them all the same, basically. So if there isn't, there certainly can be. We could include a table like that in our monthly build process or something like that without much trouble. It might be a helpful thing to put up on the web. There's already code to generate the table, so why not use it, right? Okay. The next thing that people had asked about was sniffing TCP dump traffic. Anything else that's popped into people's minds as we've gone? Anybody want to add more stuff to the agenda? How are we doing on time?
The next session starts in 5 minutes.
Okay, so we got 5 minutes left. Let's hurry. Okay, so everything we've looked at so far is looking at the slow query log, but the input that's accepted is only slow query log by default. You can consume input from sniffing the process list, just running show process list repeatedly. You can grab MySQL TCP dump traffic. It might take me more than 5 minutes to type the commands and get them right, but there are copy and paste ready examples in the documentation to do that. All you have to do is just say --type equals TCP dump, and it knows how to understand the MySQL protocol and get nice detailed information about it. Not as much as you could get with, for example, the Percona patched slow log, because some of that information is only available inside the server, but you can get anything that is available from the protocol, including errors, warnings, and there are a couple of flags like no query used, no index used, and no good index used. Those things will show up as attributes in the events. And there's actually the ability to do pretty much anything that has a request and response kind of a cycle. So the next thing that I did, after an idea, one of our partner companies, Schooner, is building Memcached appliances, among other things. And as I was talking to them at the MySQL Users Conference in April, I suddenly realized there isn't really a tool for analyzing Memcached performance. Everybody just goes, it's so fast you don't have to care, which is baloney. I mean, it is fast, but you do have to care about it because, for example, Morgan, maybe you even were the one who noticed that one of our customers, maybe it was Ryan, noticed that one of our customers was storing something global like, I don't know, the latest news headline or something like that, but they were storing it in Memcached under a key that had the user ID embedded in it. So they were storing like 1 million copies of the latest news headline, right? So those are the kinds of things that you want to actually be able to measure and understand about your Memcached server, as well as the response time, you know, which queries are you making to Memcached most often. So, so over one weekend I decided to write a Memcached protocol parser. So you can grab TCP dump your Memcached traffic and then say --type equals Memcached, and poof, suddenly it's like, hey, Memcached makes queries too, so it aggregates and reports exactly the same way. And over the last couple of days, Daniel has been writing an HTTP protocol parser. So, I mean, what is a web server except something that you make requests and responses to, right? Plain old web surfing, you have GET and POST and all of those kinds of requests, and there's a uniquely identifiable argument in there www.percona.com/contacts.html. So we can treat those exactly the same way. And not only that, but these things, pretty soon you'll be able to write your own and just refer to, we'll have documentation on how the module works. You should be able to write your own, put it into a Perl module, put it on disk and say, use this. And whatever I'm giving you, use that as the parser and thingy to extract events out of whatever input you're getting. So there's that whole concept of the pipeline, the creating query events out of the front of the pipeline is just one little thing that we can abstract out and use this tool for lots of different purposes. As one example here, we like to optimize the entire application. So the client might say, I have some pages on my site that are slow, or I think I might, but I'm not sure which pages on my site might be slow, and I don't have good instrumentation. Well, we could start by TCP dumping their HTTP traffic, analyze which requests on their site are actually slow, and with a little bit of magic, we could actually tie that to specific process IDs. At the same time, we could be TCP dumping their Memcached traffic and their MySQL traffic, which with Netstat we could tie to the same process ID. So we could even identify this page load caused this query and this Memcached query to be run. So you'd be able to tie all that stuff together. Sphinx protocol is the next one that I want to work on. And oh, by the way, there are lots and an increasing number of different kinds of tools and databases that are using Memcached as their native protocol. And I saw that BlackRay is using the Postgres protocol. So if we add a protocol parser for Postgres, then we'll be able to analyze Postgres traffic and BlackRay traffic the same way. CouchDB uses HTTP as its protocol. Okay, we're done.